Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 16 to 20 of the Algebra 1 Common Core New York Regents exam for January 2017. All right, let's take a look at question number 16. That says, which is a solution to the system below? Okay, so we have four options. The one that is a solution to the system below is the coordinate pair that satisfies both inequalities. Okay, so something to keep in mind, you want to note that the solution must satisfy both inequalities. You have a system of inequalities here. Okay, it's not just one. All right, so what we're going to do is just plug and chug, plug in the different options that we have and see which one generates a true statement for both inequalities. Now, if you take a look at inequality number one, you notice that the three numbers have a greatest common factor, which is 2. So we can simplify this so that our problem solving process will be easier. Okay, so we can go ahead and divide everything by 2. Okay, well, you know what, let me rewrite it so you can see it clearly. We have 2y is less than negative 12x plus 4. That was the first equation, so what I'm doing is dividing everything by 2. The orientation of the inequality doesn't change since we're dividing by a positive number, so less than negative 6x plus 2, and then the other y is less than negative 6x plus 4. Okay, so let's call this equation 1, and this is, inequality 1 and inequality 2. So let's test the first option, option 1, where we have the coordinate pair 1 and 1/2. So what we'll do is plug in x for the x's in the inequalities and then y for the y's in the inequalities. Okay, so let's start with the first one. For the first one, we'll plug in 1 for y, so 1/2. Is 1/2 less than negative 6 times 1 plus 2? Is this a true statement? 1/2 is 1/2 less than, multiply this, negative 6 plus 2 is 1/2 less than negative 6 plus 2 is negative 4. This is no, 1/2 is not less than negative 4. 1/2 is greater than negative 4. So number 1 fails early in the game. So we jump to option 2 and test that out with both, test the coordinate in both inequalities. Okay, so option 2, we have the coordinate pair 0, 6. So this is my x and this is my y. Let me just rewrite the inequality again. So the first inequality is y less than negative 6x plus 2. So we substitute. Is 6 less than negative 6 times 0 plus 2? Is 6 less than 2? That's false. 6 is not less than 2. This was false also. What we're looking for is the one that generates a true statement. So option 2 fails the first inequality test. It doesn't generate a true statement. So let's jump to option number 3. Let's see if this one works. So for option 3, we have the coordinate pair negative 1/2 and 5. So this is my x and this is my y. We're going to plug it into the first inequality. Y is less than negative 6x plus 2. So the question is 5 less than negative 6 times negative 1/2 plus 2? Is 5 less than negative 1/2 times 6 you can cross reduce. Okay, 2 goes here, 1, 2 goes here, 3. Minus times minus is a plus, so we have 3 plus 2. Is 5 less than 5? No, 5 is equal to 5, so this is false. Okay, so by method of elimination, we can easily conclude that the answer is option 4, assuming we didn't make any mistakes in any of these options that we just took a look at. So let's verify that the coordinate pair -3, 2 satisfies both inequalities. Let's test the first one. Y is less than -6x plus 2. Plug it in. Is 2 less than -6 times -3 plus 2? Is 2 less than -6 times -3 is 18? Is 2 less than 18 plus 2? Is 2 less than 20? Absolutely, this is true. So we're looking good here. Does that mean that this is the answer? No, we have to make sure that it satisfies both inequalities. Okay, so inequality number 2 is y less than -6x plus 4. Plug in 2 for y. Is 2 less than -6 times x? You plug in -3 plus 4. Is 2 less than 6 times 3 is 18 plus 4. Is 2 less than 22? It certainly is, so this is true. So since the coordinate pair in option 4 satisfies both inequalities, this is one of the solutions to the system of linear inequalities. Okay, you have infinitely many solutions because you're looking at the intersection of the regions here to see what the correct solution region is for the system of linear inequalities. All right, let's take a look at question 17. It says, when the function f of x equals x squared is multiplied by a value a, where a is greater than 1, the graph of a new function g of x equals ax squared opens upward and is wider, opens upward and is narrower, opens downward and is wider, or opens downward and is narrower. So if you remember your rules for transformation, this will be a very easy problem. If a is greater than 1, it shrinks, it stretches the quadratic function vertically, which makes it look slimmer. And since a is positive, it opens up. Okay? So just based on the value of a, you can easily see that the answer is option 2. But let's assume that we do not have the rules memorized. So all we're just going to do is pick an a value. So let a be what? Any number bigger than 1. 2. So what we're going to do is we're going to compare the graphs of the original function, x squared, and the transformed function, 2x squared. Since we can use our calculators, we might as well graph both of them, and it's easy for us to answer the question. So let us go ahead and input the two functions into the calculator. The first one is x squared, the original. Let's graph that. I want to center it, zoom 6. Have it centered for us. Okay, now I'm going to graph y equals 2x squared and see how it compares with what I just have. Okay, 2x raised to the second power, enter, and graph. So this is the original. What just happened? The one that we just graphed opens up. Is it wider or narrower? We can clearly see that it is narrower. Okay, so based on the results from the graph, it's easy to conclude that our answer is option number 2. Okay, so what's happening is the narrowness of the original function that we have compared to the original, of the transform compared to the original, is a result of stretching the function vertically. Okay, that's why it looks narrower. All right, let's take a look at question number 18, it says Andy has 310 in his account. Each week W, he withdraws $30 for his expenses. Which expression could be used if he wanted to find out how much money he had left after 8 weeks? Okay, so he starts with $310 and he's going to be taking out $30 for each week W. Okay, so let's say for 1 week, for instance, how much did he take out? He took out $30. Okay, so for the first week W, he took out $30. So we have 310 minus W times 30. Okay, or this can be written as 310 minus 30W, where W basically represents the number of weeks. So week 1, we have 310 minus 30, 2 weeks, 310 minus 30 times 2, and then you just go on and on like that, okay? So let me just give you some example scenarios to help you understand what's going on here. So for week 1, we're going to have 310 minus 30 times 1, okay? Which is 310 minus 30. For week 2, we have 310 minus 30 times 2. Okay, so you see why we're multiplying 30 and W, because W represents each week. Okay, minus 60. Okay, so we have the formula to determine how much he has left in his account. So let's call it L of W is equal to 310 minus 30W. So this is the expression, this is the function, with this is the expression part of the function that can be used to determine how much money he has left in his account. But how many ways can you write an expression? There are infinitely many ways, right? So what we're going to do is let's compare this function expression with all the expressions we have here and see which one is equal to 310 minus 30W. Okay? All right, let's take a look at the first one. That's totally wrong because of the 8 right there. Let's grab that. Option 3, 310, no way. You multiply W by the $30. Okay, you don't multiply it by how much he has in his account. Now, let's look at 2 and 4. If we simplify those, do we end up with this expression here? So let's start with option 2. 280 plus 30 times W minus 1. When you simplify it, you have 280 plus 30W minus 30, which is equal to 280 minus 30 is 250, okay? 250 plus 30W. Is that what we're looking for? No. Number 2 is a fail. So we can easily conclude that option 4 should be our correct answer. But is it? Let's go ahead and simplify this completely and see if these two are equivalent expressions. So 280 minus 30 times W minus 1. You distribute negative 30, not just 30, okay? Distribute negative 30. So that gives you 280 minus 30W. And what does this become? Plus 30. Okay, minus times minus is plus. Now we combine like terms. 30 and 280, when we combine those two, we end up with 310 minus 30W. Ladies and gentlemen, we have a match. Answer for number 18 is option number 4. Okay, let's take a look at question number 19. It says the daily cost of production in a factory is calculated using the function c of x equals 200 plus 16x, where x is the number of complete products manufactured. Which set of numbers best defines the domain of c of x? Okay, so see, the domain is what? In or out? Input or output? So recall that your domain is the input values, the acceptable input values that results in the function generating defined outputs. Acceptable input values, okay? And then when you plug in these acceptable input values, the resulting output values are forms your range. Okay? All right. Now, what's the input here? You see C of x? C of x basically tells you what the input is. Whatever goes into the parentheses, that is your input function. So we're looking for the set of acceptable x values for this function. We're told that x is complete products. Okay, so how do you count those? Complete products. Examples are 1, complete product, 2, 3, and on, okay? There are no fractions, there's no zero here, it's just complete whole numbers. That's exactly what we have. Now option 1, does option 1 define the domain? The answer is no, because integers involve negative whole numbers. So integers include -1, -2, 1, 2. So because it includes negative numbers, which is unacceptable, this is eliminated. Okay? Because negatives do not work. You cannot produce negative items. Number 2, positive real numbers. Real numbers includes rational and irrational numbers. So you could have 1/2, 1/4. These are fractional and they're not complete products. They represent a fraction of a product. So that should be eliminated also because fractions do not work. Fractional products. How about positive rational numbers? Positive rational numbers include any number that can be expressed as an integer divided by an integer. For example, 1/2. This is rational, is also real. 3/2. These are incomplete products, and they do not fit the description of the domain, which requires completed products. Whole numbers are 1, 2, 3, perfect match. Our answer to question 19, the acceptable domain for this function, are the set of whole numbers. All right, let's take a look at question number 20. It says Noah conducted a survey on sports participation. He created the following 2 dot plots to represent the number of students participating by age in soccer and basketball. So we have the dot plot here, and we have the following questions. Which statement above the given data set is correct? First one, the data of soccer players are skewed right. Okay, so if you look at the distribution of the dots, the direction, either left or right, that has the higher number of dots indicates the direction of the skew. Okay, so if you have more dots in one area than the other, then you're skewed in that direction. Okay, so if you look at the soccer player's situation, do you have a lot of points to the right? This is right here, to the right. Do we have a lot of points here? The answer is no. It appears as though there's even more points to the left, 1, 2, 3, as opposed to the one that you have here. If you just cut it down the center, right there, you have more points, data points to the left than there are to the right. So what does that tell us about the data set for soccer players? This one, believe it or not, is skewed Let me put it on this side right here. The soccer player's stats is skewed to the left. Okay, is skewed to the left because you have more data points to the left. Now, if you take a look at the basketball player data plots, it's clear that it's skewed way to the right. You see all the points clustering over here. To the left, there's barely anything. So the basketball data plots is skewed to the right. Okay, so option number 1 is incorrect. The data for soccer players is not skewed right. It's actually skewed left. Question 2, for the data for soccer players have less spread than the data for basketball players. Okay, so basically the spread is we're looking for the numbers that have data points on them for the statistics that was collected. Okay, so if you look at the number of student participation for soccer, it goes from 6 all the way to 12. Okay, so your spread here is basically the range from the smallest to the highest number, okay, of data values for your dot plot. So your spread here is simply going to, let's do soccer player first. For soccer players, your spread is from goes from 6 all the way to 12. Okay, and then for basketballers, the spread goes from 6 all the way to 12. So how do they compare? Do you have a narrower spread for, let me check the question again. Soccer players, it says the data for soccer players have less spread. So if you look at the range, the interval here, is that of soccer smaller than that of basketball? That's false. The spreads are equal. Okay, this is wrong because the spread is equal for both of them. Okay, they both have a range from 6 to 12. Now, let's take a look at option number 3. It says the data for basketball players have the same median as the data for soccer players. Now, based on the skew direction, we can automatically conclude what the answer is. We can conclude that this is false. How do we know? We know that because the median goes in the direction of the skew. So if you look at the soccer players' data plots, for example, the median, because it's skewed to the left, the median is going to be towards the left. And then if you look at the data set for the basketball players, since the data set is skewed to the right, guess what? The median will be closer to the right. So are they going to have the same median? The answer is absolutely not. One is tilted to the left and one is tilted to the right because of the skew in the data set. Last option, the data for basketball players have a greater mean than the data for soccer players. So that should be the correct answer based on elimination. Okay? But let us go over number 3 and 4 by actually listing out the numbers in order and then calculating what the median and the mean values are, so we have a concrete idea of what those values are and we can carry out more accurate comparisons. Let us start with the soccer player ages. So what do we have there? We have 6, 6, 6. And then for 7, we have 4 sevens. 1, 2, 3, 4. And then we have 2 8s, 8, 8. And 2 9s, 9, 9. And then how many 10s do we have? 3 10s, 10, 10, 10. And then we have 2 11s. Let me shift this to the left a little bit. And then we have 2 12s. Okay, so 12, 12. So you see, look at the numbers, you see how it's skewed to the left? So that basically would tell us that our median will be somewhere close to the left. So let's figure out what the median is. We'll basically count the number of numbers and locate what the midpoint is, and that will be a median, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so we have an even number of data plots here, so we will have to do some averaging, okay? We pick the two middle ones and then we will average them out. If we had an odd number of data points, then that center value will be our median. So just go 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry, I'm supposed to go all the way to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Bam, right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what's the median? We just simply average those two out. So the median for soccer is going to be 8 plus 9 over 2. 8 plus 9 is 17 divided by 2, which is 8.5. Now, for the mean, we're just going to look at the sum of the numbers divided by the number of numbers. So for that one, we're just going to do the following calculation. Let me move this back. Okay, so the following calculations, we're going to do 6 times 3 plus 7 times 4, just to save time, plus it's 16, plus for the 9s, 9 times 2, 18, plus 30, plus 22, plus 24. And then we divide all that by the number of numbers, which is a total of, we counted 18, right? So just do that in our calculators. Okay, when you do that with your calculator, I just did it with my TI-89 here, you get 8.6. Okay, 8.6 repeating, that's your mean for soccer. Okay, now we're going to shift gears and take a look at basketball. Okay, so for basketball, let's go ahead and find out what the median is first. Remember, we talked about the skew direction and how it affects the median. We can see that this one was closer to the left, kind of sort of, was skewed towards 8.5, the median, and our expectation for the second one is that the median should be closer to the right. It should be bigger than 8.5, okay? So let's do the median first. So let's order our data set. So we have 6, 7, pardon my skinny font, I'm trying to make everything fit, 8 and 8, and then how many 9s? 1, 2, 3, and then 10s, 1, 2, 3, and then 11s, 1, 2, 3, 4, and then 12s, 1, 2, 3, 4. Okay, just look at the numbers. You see that it's skewed towards the right end. Now, what's the median? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, where's our median going to be? At the center, right? We have 18, so we have to average again. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's halfway. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So our median for basketball is going to be 10 plus 10 over 2, which is 10. So you see how it's skewed to the right? The median is in the direction of the skew. It's kind of to the right more than this one. Okay? So that's why it was easy for us to eliminate option 3, which indicated that the median of both data sets were equal. That's not possible because of the differences in their skew. Okay? Now, let's take a look at what the mean is so we can seal the deal and know if option 4, because based on elimination, we know that option 4 is the correct answer, right? But let's actually work out the whole problem. So if we do this, we're going to have 6 plus 7 plus 16 plus 9 times 3, 27, plus 10 times 3, 30, plus 11 times 4, 44, plus 12 times 4, 48. Okay, that's the total number divided by the number of numbers that we have. We have 18 total. Okay, so let's go ahead and use our calculators for this. Okay, so I have it at my calculator right here. Divided by 18. Approximate answer is 9.8. Repeating, okay, so that's what our mean is going to be, 9.8 repeating. 9.8 repeating. So option 4 says that the data for basketball players has a greater mean than the data for soccer players. Is that the case? The mean for basketball players is 9.8 and the mean for soccer players is 8.6. So the mean of the basketball players is greater. Bam. Option number 4 is correct, as we thought earlier that was the correct answer. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the Algebra Common Core Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to respond. We update videos to our page on a consistent basis, so do subscribe to our YouTube page for updates on other cool tutorials, including the remainder of this review series. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.